Hi everyone, welcome back to my channel. Today we are going to solve nuclear chemistry CSIR previous year questions from 2011 to 2012. In this part 1 to part 4, a video link I have mentioned in description. Please go through that. Now let's see the question. Here, this question has asked in CSIR June 2011. For a given fission, for a given nuclear fission reaction of uranium 235 uranium 92 plus neutron gives rise to 142 barium 56 and Kr 91 and 36 plus 3 neutron. Here the amount of energy in kilojoule per mole released during this process is calculated using the following data. Here mass of uranium 235, mass of barium 142 and 56 and mass of strontium 91 and 36 and mass of neutrons are given. Well, let's see the solution. Here four options also given. Now see the solution in step by step. In step 1, you have to calculate total mass of reactants. So mass reactants is given as uranium 23592 and neutron. So here data has given for this. I will check the mass of reactants. So mass is equal to 235.0439 plus 1.00866. So answer will be 236.05256 am. In step 2, you have to calculate total mass of products. Here products given as barium 142 and Kr 191 and 3 neutrons. Here those values are given. We'll substitute into this. Mass is equal to 141.9164 plus 90.9234 plus 3 into 1.00866. That is equal to 141.9164 plus 90.234 plus 3.02598. That will be equal to 235.86578 am. Now we got both total mass of reactants and total mass of products. Let's see the step 3. Here we have to find out mass defect. Mass defect delta M means mass of product, total mass of product minus total mass of reactant. So substitute the value. 236.05256 minus 235.86578. That is equal to 0.18678 AMU. In step 4, energy released in mega electron volt, that is 1 AMU. That is 1 AMU is equal to 931.5 mega electron volt. E is equal to 0.18678 into 931.5. That will be equal to 173.96 mega electron volt. Now, in step 5, convert to joules. In question, they have asked in kilojoule per mole. So, you have to convert to joules first. 1 mega is 1 mega electron volt is equal to 1.602 into 10 to the power minus 13 joule. So, E is equal to 173.96 into 1.602 into 10 to the power minus 13. That will be equal to 2.786 into 10 to the power minus 11 joule per atom. In step 6, we have to convert to kilojoule per mole. E is equal to 2.786 into 10 to the power minus 11 into 6.022 into 10 to the power 23. For this energy, we have to convert into, you have to multiply into Avogadro number. That will be equal to 1.68 into 10 to the power 13 joule per mole. That will be equal to 1.68 into 10 to the power 10 kilojoule per mole. So final answer will be option D is the correct one. 1.68 into 10 to the power 10 kilojoule per mole. Now let's move to the second question. This also asked in CSIR June 2011. The species 19 neon 10 and carbon 14 6 emitter positron and beta minus particle respectively. The resulting species formed are 19Na and 14b. Option B is 19F and 14N, and option C is 19Na and 19Na and 14N, and option D is 19F and 14b. We'll see the solution. First, we have to check the rule. The rule is in beta plus and means positron emission, atomic number Z decreases by 1, and in beta minus emission, atomic number Z increases by 1. In both cases, mass number A remains same. Now, we'll see the solution in step by step. In step 1, for neon 10 and 19, in this positron emission will happen. So here Z decreases by 1. That means 10 decreases to 9. So the resulting nucleus will be F19 and 9. In step 2, for carbon 14 and 6, beta minus emission will happen. Here Z decreases by 1, increases by 1. Here 6 will increases to 7. So the resulting nucleus is nitrogen 14 and 7. The final answer will be option B is the correct one, 19F and 14N. This is the correct answer. So we'll move to the third question. This has asked in CSIR in December 2011. For the nuclear reactions, here two conditions given, A and B. Beryllium 8 and 4 gives rise to 2 helium, and Kr 80 and 36 gives rise to 2 Ar 40 and 18. Here the respective masses also given, and the correct statement is here 4 options are given. A and B are both spontaneous fission processes. A is spontaneous fission but B is not. In C, B is spontaneous fission but A is not. Both A and B are not spontaneous fission processes. Now we'll see the solution. In his concept used, the reaction is spontaneous if Q greater than 0. Q is equal to mass of reactant minus mass of products. For A is beryllium 8 4 and 2 into helium 4 and 2. Here respective masses given, we'll substitute in this. So Q is equal to 8.005300 minus 2 into 4.002603. That is equal to 8.005300 minus 8.005206. That is equal to plus 0.000094 AMU. So here Q greater than 0. That means the reaction is spontaneous. Now we'll see the B. Q is equal to 79.91638 minus 2 into 39.9623A. That gives us to minus 0.00838 AMU. Here Q less than 0. That is not spontaneous. So final answer option B is the correct one. Here A is spontaneous fission but B is not. Now let's move to the fourth question. This is asked in June 2012. The carbon 14 activity of an old wood sample is found to be 14.2 disintegrations per minute per gram. Calculate the age of the wood sample. If for a fresh wood sample, carbon 14 activity is 15.3 disintegrations per minute per gram. So half-life of carbon 14 is equal to 5730 years. Here 4 options are given. We'll see the solution in step by step. Here given data. Initial activity, that is fresh wood, A0 is equal to 15.3 dpm per gram. And activity, that is old sample. Final activity, A is equal to 14.2 dpm per gram. Half-life T half is equal to 5730 years. Here formula used, radioactive decay log. A is equal to A naught e to the power minus kt. Taking logarithm, T is equal to 2.3 divided by k log of A naught by A. where K is equal to 0.693 divided by T half. Now substitute the values. In step 1, calculate decay constant K. K is equal to 0.693 divided by 5730. T half already they given. So K is equal to 1.209 into 10 to the power minus 4 per year. In step 2, substitute in formula. T is equal to 2.303 divided by 1.209 into 10 to the power minus 4. That into log of 15 0.3 divided by 14.2. Now we'll solve this ratio. 15.3 divided by 14.2 is equal to 1.077. We'll take the logarithm of that. Log of 1.077 is equal to 0.0329. Now we'll substitute this in this equation. T is equal to 2.303 divided by 1.209 into 10 to the power minus 4 into 0.0329. So finally we will get 617 years, 627 years. That will be approximately equal to 617 years. So final answer T is equal to 617 years. See, here this matches with option D, 617 years. This is the correct answer. We'll move to the fifth question. This also asked in CSIR in June 2012. In carbon dating application of radioisotopes, carbon 14 emits option 4 options given: beta minus particle, alpha particle, gamma radiation, and positron. We'll see the concept. Here, decay of carbon 14 means 14 carbon 6 gives rise to 14 nitrogen 7. It undergoes beta minus decay. Here, it emits an electron. Keep this in memory. Beta minus decay. In beta minus decay, electrons emitted, that is used in carbon dating. So here the correct answer is beta minus particle. I hope you understood this video. Part 6 will be coming soon. If you like this video, please like, share and subscribe to my channel. Thank you. Have a good day.